Hello there. In this video, we are going to set up a network secured with firewall for our home or a small office. Now first, let me talk about the physical topology. We do have our ISP router connected to our Proxmox server or a desktop with VirtualBox. And then we have the L2 switch or an old router to be reconfigured as your own switch. And this router or switch is going to supply or provide internet access to all our appliances. Now, what is the concept behind the firewall? The firewall is going to serve as a filter. It's going to pass or drop traffic based on the rules that we are going to set up in it. So for this firewall to work properly, it needs at least two cards. There must be two cards. So we have one interface, and this is served as the input. The traffic is coming from your internet through this ISP provider router here, and then after its magic with the rules inside our pfSense virtual machine, it will go then to the LAN interface, which will handle it over to the L2 switch. So this is the physical layer, and for the pfSense, it will be a virtual machine installed either on this Proxmox or the desktop VirtualBox, but in our case here, we're going to install it on Proxmox. And we do have the OVS. OVS stands for Open Virtual Switch, and it's a multi-layer switch. Why do we need it? Because here, if we want to apply the concept of the VLAN, I may have some, for example, a VLAN of home here. This can access anything in this network. And then if I have a guest, some visitor, or what we call the DMZ, that's something different. DMZ, we store, for example, our websites, for example. It's not going to be, of course, on premises of the home, but I'm just trying to describe this DMZ concept. Just like the guest, it's something here that's we need to provide access to internet, offer access to internet, but it cannot access any of this. This is the concept of the guest. If I have a guest, for example, a friend or whatever, okay, I need to offer him this internet access, but without being able to access my stuff. And the same for the DMZ. If I'm hosting, for example, my e-commerce website or my website here, this is a company, I don't want for this website to have access to my internal network, but it will have access to the internet for security. If this system or server is breached, at least we are going to limit this to this server to not expand it here. And this is that's the name of the firewall. The firewall, something taken from the building of the constructions. They used to build this firewall to spread or stop spreading of fires. That's the name inconvenient came from this. So as we said, we are going to have one interface and an interface. And first, we need to have this filter as input and output. And then we have a third interface of this OVS. For us to implement this VLANs, as we said, the VLAN 100, VLAN 200, we need to either have a layer 3 switch, multiple switch, managed switch, or a router. And this will not be affordable most of the time. So OVS stands for Open Virtual Switch. It's an open source free project, free to download, open source project, free to download, and it's easy to install. So our server or PC will be chipped with only one physical interface card. We are going to use this LAN card as the management for this server and as the LAN port for the pfSense. And we have another one separately purchased and installed on this machine. It's Intel chipset. And the reason for this Intel chipset is that it's compatible with the drivers of the Proxmox and the ESXi VMware. So we have two physical cards. One interface is going to be the input coming from the ISP router, and the LAN will provide its traffic to the L2 switch after the magic comes inside the pfSense of the rules that we are going to create. And this OVS bridge is going to be the third interface installed on the pfSense. Please note that the WAN and the LAN interfaces are physical. Both are the physical interfaces, but this one is going to be virtual. We will install it first on the server or the S level, and then we are going to attach it to the pfSense virtual machine. Now, for better security, it's recommended that you change your default admin password for your router, and so for this IP, most vendors configure the router to be 192.168.1.1. It's better to be changed. This is our private IP address ranges. It's the ranges that's reserved for private use. By private use, we mean that they are not reroutable outside your internal network. For example, I do have here a home internet router, so does my neighbor. So we both are 192.168.1.1. We cannot have any conflicts with each other because this is internally used inside this borders of this network. So that's why we have external IP here. It's the one that exposes to the internet. Most of the time it's dynamic. It'll be static only if you pay a fee, you ask for it, but most of the time it's dynamic. So traffic goes here and then through this one interface. So it's best practice we choose this to be 172.16.0.1/25. Of course, you can choose whatever range that's best fit for you. For the LAN, it's going to be 10.15.3.1/25. When I installed the server, I did have this manually installed on Proxmox, and of course, my PC was statically also configured on this same subnet. You can access and set up this PC. This was going to be the IP 10.15.3.1. This will be the IP for the pfSense. Okay, now let's proceed to our server. Okay, we do now first go to ISO images. We navigate to this local hard disk, ISO images. I've already downloaded the pfSense Community Edition 2.7, and the reason I didn't download from URL directly is that although it was .iso file, but it was a compressed that need to be extracted first and then uploaded here. It's free to download. Just navigate to Netgate, download this pfSense, and then we are going first to check our server. We do have 4 cards installed, physically 4 cards, but I did say that I'm using EN01, the first one, to be my LAN card, so automatically when installing Proxmox, a Linux bridge was created by the system. We are going to use this second one as our WAN interface, which means that we need to hit create. Sorry, I just want to pick up this copy. Don't want to misspell. Create, then Linux bridge, and we're going to paste this here. This is our port. The port means that which interface you're using, and we are going to say this is WAN. And for this range, it's 172.16.0.1/25. It was the one in the diagram, the topology. Create, apply configuration. Okay, one more thing that here, as I said, I picked up this is as the LAN and this is at the WAN, but this is for me. For you, you can do it differently. It's okay, it's up to you. The important point is that you must note which one are you using for LAN and which one you assign for the WAN and LAN, because when we install pfSense, there will be little trigger about this sequence. So let's create virtual machine, pfSense for the OS, pick up 2.7 for system, leave as it is. I'm going to have this as 100 gig because I'm going later to install some packages like the Snort. For CPU, I need it to be 2, but it's okay for 1. RAM, I needed 4 gig. That's okay also for 2. For me, I'm going to use this as main interface in the home network and my lab. so I need to have stronger sources. Now, no network device, that's because we are going to attach them. This is the part what I told you that it's going to be tricky. Okay, now our pfSense is ready, but please let me in this option start as biddable, meaning that if I have a power failure and we need power back, no internet, so you ask anyone, just please press, when the power back, press this server of the button of the server, power it on, and automatically boot up and internet will be back. Now, hardware, and this is the tricky part I was talking about. Please note that the pfSense, as a configuration, it will accept the first card as the WAN. It will see it as the WAN. We know that this is my LAN, so I am going to assign this as the first one, and here we need to pick up this Intel. You are going to use this for other software, but here we need it to be Intel E1000, and then we are going to repeat this again, but this time it's going to be our LAN, because the second interface for pfSense is the LAN. We are going again to pick this as Intel and click add. I think now we are ready to go. Let's hit start and cancel. Okay, accept, and we are going to accept all the default parameters. Just press spacebar to select it, enter for OK, left arrow and enter for yes. Yes, sir. Please reboot. Okay, now we're up after the reboot. So right now we see two interfaces. This is the WAN. As we said, this is EM0. And this is not as our server, it is the default settings for the pfSense as a virtual machine that will accept the first card as the WAN. That's why I told you, please pay attention for this part. And the second is LAN. Now we have 172.168.0.10, which means that we are successfully installed it because it took one IP from our router range that was specified in our topology 172.168. And this is the default, which we are going to change because this is not ours. We are going to have it 10.15.3. So we need to change it first before we proceed. So here, set interfaces IP address 2. Then 2 for LAN. No, thank you. 10.15.3.1. 25. No, thank you. Enter. No, thank you. No, thank you. Enter. Okay, now we're good. We do have our WAN as it is, and then we configured our LAN interface. Now we need to navigate to our LAN, to our pfSense. Okay, we're in, proceed. Okay, this is the default here. Username is going to be admin, small, and the password is pfSense, small also. Next, and here I want it to be HomeLab. So this is the pfSense. This is the name of the virtual machine that we specified at the beginning. This is the fully qualified name. So my domain here is HomeLab. This is my server name. You can change this, of course. Then we leave this as default, we'll change it later. Next. And here we're going to pick up Cairo. Next. Leave this also default. Next. Next. And then we have our need to changes. Reload. Finish. Accept. Close. Okay, now we need to set up some configuration. So system, general setup. And here we're going to be using Cloudflare. 1, 2, 3, 4. And here's the documentation. This documentation shows you that how to configure the DNS. The reason here is that I need to use Cloudflare as my local DNS for the pfSense. Remember now that your internet service provider is almost out. We do not going to use it. We won't use it anymore. And even if it's have a wireless enabled, it will be disabled because it's no more serving us. We are all having our traffic behind this firewall. So this is the configuration we're going to have. This is okay. Okay. Let me see here. 110. Okay. Now we need to uncheck this. And then here we are going to use local DNS, the second option, 127.1. Why are we using this? This is our local DNS now, and it was empty, but we configured it now with this Cloudflare interest. It will be much better and safer. Now let's get down, click save. Okay, now let's go to the DNS resolver. Okay, let's get down here, uncheck this please, and enable forwarding mode, use SSL TLS. Let's save, apply changes. Now since we're going to be connected to this, we need to enable the DHCP. I'm sorry, it's here, the service, here. Enable. This is the range, our acceptable range. You can change it if you want, but that's okay for me. Now let's click save. Okay. Can we just Google? Yes, sir, we can. That's good. Now, we need the part of the installation of the pfSense. Now we need to go back here to check out this for the OVS switch. So, we did say that we have two interfaces, physical, but there is one that's going to be virtually added. It's the OVS bridge. Before this, we need to install the OVS. So we go to shell. I'm pointing to the server. Navigate to your server and the shell. Okay, and now we're going to apt space update. Hit enter, and then followed by the another command, apt space install space openvswitch -switch. Hit enter, and you're going to find both in the description with the this article of the configuration of the DNS. I did this before, so I'm not going to repeat it. Then we are going to this network on this on the server lab. I mean the server level. Sorry, network. We're going now to create what we call OVS bridge. Just here we need to say VLAN interface. Create, apply. Okay, now we are ready. Here we have our LAN, our WAN, those are the physical networks, and this is our virtual one. it's installed on this network. We need just to go to the pfSense, virtual machine, and hardware. Then we need to add this. Okay, we already have LAN, and then we have this. Okay, so now the pfSense is ready for this implementation of the VLAN. Before we do this, we need to move as follows. To do this implementation, you need to navigate back to your server node, network, then you create, this time, OVS interport. And now I'm going to say this, for example, this is VLAN 100. Okay, and we need to add this here also, 100. So please note that you need to specify this as this. The VLAN tag is always only numbers and have to match this so that we are not going to be conflicted, because later on we will link this to the pfSense by this number. Okay, we create this. If you wish, we can do this like home, to be specifically, create, and then we are going to create another one, and this time it's VLAN, this is 200, and it's called the DMZ, and we are going to write here 200, create, now hit apply configuration. Okay, now we can now go to our pfSense. Then we navigate to interfaces, assignments, then go to VLANs. There is nothing, so we need to add. Here we are going to add this. Now we know this is WAN and LAN. We need this card because this is the third card that we installed virtually of the OVS bridge. Then we write here the number, only the number. In this description, we may write this, for example, VLAN 100, home, save. We may add another one on the same interface card. We're going this time to pick up 200. VLAN 200 DMZ, save. Now we need to go here to assignments, and then we need to pick up first one, VLAN add, then we choose it, enable. Now this is going to be our VLAN 100 home. We are going to type this static. Let me please check. It was, oh, here it is. Here it is. I think this is supposed to be 1. This was the IP of the machine. You can do this for 24 or to 5, but I'm stuck with 25. It's okay for me. Now we need to apply this changes. Oh. Okay, setting, I hate it for double. That's okay. Now let's navigate here to interfaces again. Here we have assignments. Now let's add this new one. Here it is. Add. And then we enable VLAN 200 DMZ. And here's the static configuration. And this is gonna be 25. And this is, I believe that this was 2. That's it. 2.1. Just let me check my diagram, please. 2.2. Okay. 2.1 is fine. Now hit save. Apply. We're good. Now we need just to go to the DHCP server, because as we did with the LAN, we need to do this. When this is something like a new card, a new interface card. So when you assign some appliance there, this appliance need to acquire its own IP. So we need to enable this surface, and we are going to just take this like that. then we hit save. Okay, the second one, we're going to do the same. Sorry, enable, and then we're going to pick this up. We're going also to pick this up, get down, hit save. Okay, now we're done. Okay, now we have here for the assignments, you have WAN, LAN, and the home and the DMZ. Okay, in order to begin to use them, we need to set up our firewall rules. Okay, already we have our WAN and LAN, they are default rules. Okay, now we need to have this VLAN is going to access everything. So we're going to hit add, and please let me just tell you that if we get back here, how does this is the magic that we were, the concept behind the firewall, that for every traffic that's going to be coming here from the WAN as an input, it's going to have a source destination, of course, and the most important is that we are going to either pass or drop this. And one more thing, that this work as from top to bottom, meaning that the firewall will apply this rule and next rule and next one, and so on. So it's from top to bottom. So it's very important to consider your ordering or your sequence of this rules, because if a rule is misconfigured, then it could result in some vulnerability, like a passing traffic that we don't want. Okay, now for this home, it's very simple. We're going to add this. Here we have a pass or block, and pass is going to pass it, block is going to drop it silently without anything. It means the other side is going to receive as timeout. Reject means that we inform the server that we rejected your request. This will be pass. And then we have the interface, because we have WAN, LAN, and the 100 and the 200, I mean home and DMZ, but this is the interface of home we're talking about. And then the protocol could be anything, but we specify it will be any. And I want for the source and destination to be any to any. So this means that home has the full access to do whatever, to access whatever appliance it wants. But for the DMZ, it's not the case. First, I need to block it. We said that this DMZ is going to be like a guest of mine, that I'm going to offer him an access to the internet, but I don't want him to have access to my internal network. So we are going to add the first rule, and that we are going to block this traffic. Okay. Now, this again is the interface. We have the 4 interfaces, but this one is the DMZ. We're talking about this interface of DMZ. And I'm talking the protocol to be any protocol, not specific to anyone. And I'm going to have my source as this DMZ. We have the net and address. We are going to use the net. Address refers to the card. We need the internet, the net. Okay, and the source here will be DMZ, and the destination will be first the LAN net. LAN net means that it's my entire internal network. Okay, so here the rules, I just want to get here. This means that pass, and this X means block. So this block, whatever the protocol is IP4, of course, if this is the source, and this is the destination. So if traffic coming from the DMZ net trying to access our LAN, block it to be dropped. But this is not enough. Why? Because this will only serve us in the LAN. But we don't have this LAN only. We do have this. If we move this, it means that it can access anything but the LAN, which means maybe the internet and also the VLAN home. Okay, we can have a little exercise to prove it. First, let me please go back here, and then I believe that we do add everything on the server load. Remember that pfSense is going to have only 3 cards. It's the LAN, the WAN, or as it's sequence as per the pfSense itself, it's the WAN, the LAN, and then the bridge. But the server is going to hold us everything, even though the 2 cards that we created for these vLans. And then we're going to assign these cards. Here, we have assigned this previously as the okay, let's reset it to be much better. Now let's assign this red hat as our 100, or maybe let it be the DMZ. So to do this, we are not going to assign LAN or WAN, we will assign interface. And this, in this tag, we need to write down which number we want. We have 100 for home and 200 for DMZ. So let's make this real for the DMZ. So I'll make it 200. Okay? Now, if you go to its console, let me please log in. Okay, ifconfig. Good. First, it's accessible. It had this 10.0.2.2. If we go back here, DHCP server for DMZ, here it is. It's 10.0.2.1, 10.0.2.2. Okay, so we are in the right. Now, we are supposed to access the internet, so ping 8.8.8.8, this is Google. No. Now ping 27. I'm sorry, 15.3.1. No. Okay. Now let's ping this. Let me please reassign this to have the this will be our home. So again, this is our LAN interface, and this, I'm sorry, this is not the LAN interface. I mean, it's the VLAN interface. I'm so sorry. And this is 100, meaning this is our home. This is E1000. Did I do this here? No, it is better to be E1000. Okay. Now for this Ubuntu, it's supposed to be our home. Let's just check out which IP does it have. Okay, we got 3 IPs because I do have a Docker running inside it, so we can ignore this for now. We don't want this IP, but this is our local. Here, this is what we want. Okay, now this is 10.0.1.2. This is the one of the home. So let's ping 10.15.3.1. Good, we can access it. Now let's ping 8.8.8.8 Google. Good, we can access it. Now let's ping back our Red Hat. What was this? Sorry. Don't do this, please. Okay, 10.0.2.2. We can access it. 10.0.2.2. We are supposed to have access. Yes, that's correct. Why? Because we said that DMZ cannot access my network, but it can be accessed by my network. And this Ubuntu machine is in the VLAN 100 of the home, so this is properly configured. This is correct. Now let's head back here. Actually, this didn't work. That's because we said that we need to test it as an exercise. So let's get back to our firewall rules. And here is the DMZ. We said that we are going to block the LAN internet. Okay, we did not test if we can still access the home from here. IP config. Don't memorize, I'm so sorry. Okay, it's I'm sorry, this is for Windows. IV config. ifcom. Okay, 10.0.1.2. Let's ping this thing. 10.0.1.2. It's supposed to be pinging. Okay. Now we are going to add what you saw now, that we cannot ping anything. We denied this. Okay, so we need to allow internet access. So let's add a new rule. And then we're going to pass this interface and then protocol any. Although it's preferable to choose specific protocols, not all protocols, but it's okay, but this is just a demonstration. And for the source, it's going to be our DMZNet, and the destination is going to be any. Save, apply. Okay, now if we are going to leave this as it is, and this is, I'm talking about the sequence or the ordering of this rules. Now this rule will never be reached, because simply when this VLAN source 200 DMZ is going to hit whatever destination any, it's going to be permitted. Let's try it out now. Here it is. Let's say that we ping this. Good, we're good. Let's say that we want to ping this. Good. Ping this. It has full access now. Why is that? Because when we created this rule, we did not have it down. We said that rule moves as from top to bottom. If we change this back and click here save and apply changes, now let's read it from top to bottom. It says that block any source of DMZ to this VLAN net. Good. But Google is not, so it will pass. Right? Okay, let's try it now. We're going to ping Google. Good, it's working. Now let's try pfSense. Not working because we blocked it. Now let's try our home machine. Yes, sir, it's accessible. Why is that? Because we need to go here, and as we did with this LAN net, we need to add another rule that's going to block whatever comes from this DMZ to the home. Apply. What's that mean? It means that when you was blocking this, you was blocking everything. Okay, but we have to access to internet. To access the internet, we are going to allow this. So to not allow it, we need to add this new rule. Now it's going to be as follows. Read it from top to bottom now. If you hit LAN, you're blocked. If you hit the VLAN home, you're blocked. Else, internet, you are allowed. Let's try it now. Again, you can't, right? You see here, we could, but now we couldn't. Okay, now for the pfSense, still not. And now for the Google, we are supposed to have it. Excellent. We're done. Right now, this Red Hat virtual machine can only access the internet. So remember that we don't care about this one, we care about LAN and this. This is the LAN, and I'm telling it, if you need to access this LAN, you're blocked. You don't need it. And if you try also to access this home, you're blocked. You don't need it. But if you try to access the internet, that's okay, you're allowed. That's what I mean, that this thing, this DMZ zone can be offered the internet access, but without allowing it to have access to my other network. Now the point here is that if I only have LAN, this is fine. I don't need this, it does not exist. But what if we have other VLANs here, maybe cameras, maybe surveillance cameras, for example, or some departments, other, whatever. We need to repeat this line, this rule. We need to copy it for each of these VLANs and apply. And we need to have all blocks first, and then allowing the last one of the internet to be down there. Because as we said, that the firewall will apply rules from top to bottom. Okay, I hope you liked it and you find it useful, and thanks so much for watching. Bye-bye.